Thank you for having us. It was, as always, we participated in May as well, so we got some experience as well from that time. And the most important thing that we took away the last time was how to manage ourselves in a way to get some sleep in the night. So it was possible. So it's a better feeling to stand here now as the last time, for sure. So experience is very important.
So how much sleep did you get over the last 2 days then?
How much sleep? Well, 6 hours a night, maybe. So it's very cozy.
And how many of those coffees and Red Bulls did you drink?
I don't know. I don't have the statistics, but probably 4 coffees a day. That's my own statistics. No Red Bulls.
And your presentation, I think, was really nice. So good luck, and I'm looking forward to seeing what you develop.
Thank you. So welcome everybody. The most important question that we have to ask is why even build a digital twin? Well, first of all, because warehouse operations, so we're talking about digital warehouse, and DGB does this. These processes are very complex, so we need to visualize in 3D what is actually happening. And then we need to find the error. So if you have some problems on the conveyors or with the robots, you find it immediately. You need to find it immediately, and you need to jump to that error and see it in 3D. Then you need the KPIs, of course, what your robot did, and what is the performance of the whole system. And of course, we need to do it synchronously. It means the best way to do it, if you see the model, the 3D model, you can see the data besides it, and you see the key performance indicators. So it provides you the information where to grab in, where to adjust the whole process. And actually, we are the team who has found a solution for this great challenge. We're actually, one part of the team is REACH Solutions, and we help manufacturing companies make production more effective. And on the other side, we have MaxWhere on board, who are the magicians of 3D and virtual reality. And so, let's see what we have done so far. As we are going back a little bit from this canvas, we can see the 3D model of the whole warehouse. You can see the everything, the goods there, and in the middle we have the robot. Actually, the 3D representation of the robot. You can see a synchronous video showing the movement of the robot, and here you can see the slider where we can adjust the position. We can jump to the arrows that you can see here at the bottom, and we have a layout which can be used to jump to other places from the digital twin. What you can see here is the debugger screens. So maybe basically you can see the logs here and all the KPIs that we want to show while the robot is moving, so you can track where the performance is not the way you expected. After this, please go back one slide or one view. Anyway, we won't go back. The way how we could do this is actually this architecture. You can imagine the data is flowing inside this cloud-based or fog-based on-premise solution. You have some data lake, complex event processing. Everything is based on Hadoop and Spark data processing, and we run a robot operating system inside of this architecture, which is meant to control everything what is working in and moving in 3D. Here at the top, you can see the MaxWhere engine. You can do 3D, VR, and you can do smart boards. So you can show everything on these, and these are also web-based plugins that you have seen there on the screens. And of course, we can have a client, so you can use your own monitors to display the logs and everything in 3D as well. Okay, the business benefits of the whole thing. We can detect errors very fast. It can be used for collaboration and training in VR. We can optimize the performance indicators, and the whole thing is a very future-proof data architecture. But in addition to this, we have something also additional for you. We have a REACH data visualization engine. Here you can see the errors, 3 types of errors, and the distribution. Here you can see the robot movement patterns from the top, and we have trained unsupervised learning algorithm in order to identify anomalous patterns of the robot movement. Thank you very much. Please feel free to try the VR demo at the end of the lecture. Thank you.
Very excited about the solution. So now we have 3 minutes for Q&A. Should we do have any questions?
What would you say is your biggest USP of your solution? Also not only for this, but also for other industry.
Well, our USP is first of all the architecture, which can be scaled horizontally. So it is very, let's say, it is easy to integrate all kinds of systems into the architecture and to work, have a seamless collaboration between, for example, the ROS and your other systems at TGW. And on the other side, this MaxWhere engine provides a framework that can be used in a unique way to make training and demonstration possible.
Thank you. Impressive demonstration. Is it possible to add some intelligent maintenance stuff around, because you do some predictive in advance, and you show that actual situation? Is it possible to do some predictive maintenance out of that?
Yes, sure. On the last slide, I've shown you the surface for we call it custom analytics, where you can prototype your own machine learning systems, and then we can deploy it. So if you have the problem, you know what you're looking for, then you can prototype it there, and you can deploy it with 2 mouse clicks, so that this machine learning system receives the data from the data lake or stream data, and it outputs the prediction in another topic, for example.
How do you react on changes in the environment, and how do you avoid that you need to render everything new in the digital twin as you're representing that in a virtual reality-like environment? So how do you keep the effort low to react on changes in that environment?
I mean, how to build a new model in a fast way, for example.
Exactly.
Yes, but this is actually what the MaxWhere engine is for. So if the time we needed to bring the CAD data actually into the model and move it with the ROS, with the robot operating system, was less than 2 hours. So it is very fast to build prototypes of these models. If you have the 3D data, the framework is built in order to help prototype and production model building, actually. So it was a design principle, let's say, for the project.